Okay, so welcome back. This is part 2 in our series on understanding electricity. And part 1, we talked about some basic components and basic concepts involved with electricity and electronics. So I encourage you to look at that video to get a better understanding. In this video, we're going to look at a particular software tool that you can use. It's freely available. That will hopefully help you in your learning experience because it will simulate electrical circuits and electronic circuits. And you can draw out a circuit. If you're trying to understand, for example, how a diode works, you can draw out an electrical circuit with diodes and resistors and simulate what will happen based on the data you gave the simulator, and it will tell you what the currents are, what the voltages are versus time, so it will hopefully verify what you thought, or else you'll learn something new based on the results. Okay, so the software I'm going to show you is called LTSpice, and it's a wonderful simulator where you can draw out your circuits, and it should help you to understand electricity a little bit better because you can say, well, what would happen if I do this, and what does this do? And you can actually look at what happens. You can graph things, and you can see what's going on in the circuit. You can measure things. You can measure currents and voltages and powers and all kinds of things. So really wonderful way to help you advance your knowledge. Now, LTSpice is made freely available by a company called Analog Devices. So to get it, you go to analog.com, which is the Analog Devices website, and you will get a screen like this. And you go into the Design Center, click on that, and you can see they offer a lot of different tools and calculators and simulation models and that kind of thing. But we're going to go to the very first one, which is LTSpice. And it brings up this page where you can download LTSpice. Now, LTSpice is called LTSpice because it was originally made by a company called Linear Technologies, which was, I believe, bought out by Analog Devices back in 2016 or something like that. And it's the Linear Technologies LT version of SPICE, which is a software simulator that's been around for many, many, many years. And SPICE stands for Simulator Program with Integrated Circuit Emphasis, I believe, something like that. But it's very popular, very common, and really wonderful piece of software. So you get to the LTSpice page and you scroll down a bit. You can see here's where you download it for Windows 7, 8, 10 or Mac OS. And then they've got documentation down here that you can use later on. You probably won't need that right now, but just so you know, I'm going to show you some of the basics of how to set it up and run some simple circuits. So go ahead and download that, and I'll show you. I'm not going to go through the steps on download. It's pretty straightforward to download, install, pretty automatic. And then we'll show you how to start it up and use it. Here we go. We start up LTSpice, and this is LTSpice XVII, which is 17, version 17. You can see up here in the top left corner. And you get this, what I consider a very annoying background image in the LTSpice window. Now, when you first start up like this, you can't really do anything. You've just got this background image, and you can see all of the, up top here, you've got this, all the tools and components that you can draw your circuit with. They're all grayed out, they're unavailable. And that's because you need to first start a new schematic, which is basically a diagram, a blank diagram that you can draw your circuit on. So to do that, go to this upper left corner with this arrow, and you'll see it says New Schematic. Click on it, and you get this gray screen, and you can start drawing. You can see all of these components are now available, and you can drag and drop them and draw your circuit. The very first thing you want to do when you're starting out a circuit is you want to grab this. It's called a ground. It's a reference. The way LTSpice works is you pick up a tool or a component from this top bar by left mouse click, and releasing, and it basically, you pick it up. It's like picking it up in your hand, okay? So I'm moving the mouse. No buttons are pressed down. I'm moving the mouse, and I can move it wherever I want. And if I want to put it here, I do a quick left mouse click, and it stamps it down, okay? And I can do another one, stamp it down, stamp it down. And if I want to release this, I just do a right click and now I'm back to normal and it's gone. Okay? So that's the process you're going to use anytime you want to drag a tool or a component to make your circuit. Quick left click to pick it up in your hand, stamp it down, and then right click. Okay? You're going to want to keep doing that every time you do this. So now, first thing we want to do is get rid of these two guys because we don't need them. So we go back up here, and you can see there's a cut. The scissors is a cut tool. So again, left click, pick it up in your hand, go down here, left click to cut that out, left click to cut that out, right click to release the scissors, and now we've just released those. Now the other thing I can do is I can left click and hold on the schematic window here, and it will move, like you see, it will move my schematic diagram around. And I can zoom in and out using my mouse wheel. So I scroll it back towards me and it zooms in, and I scroll out and it zooms out. Okay? So makes it nice and easy. Now, the next thing we're going to do is we're going to add a simple voltage source, a source of voltage to operate our circuit. So to do that, we go up here and you can see this component icon right here. We're going to click on that and it will give us a library of all the components that are available that we can use in our circuit. Okay? And these are things like integrated circuits and complex different types of circuits. But we're going to forget all that and just scroll to the far right to where we get a voltage source. Okay, so click on that and you can see it will give us a voltage source, either DC, AC, or whatever. So hit OK and you see I've picked up that voltage source with my mouse button. So again, left click to stamp it down, right click to release it. Okay, so now I've got a voltage source. But as with any component in LTSpice, you need to tell it what values you want. So the first thing you do when you add a component to your circuit, you right click, you hover over it and right click, and you tell it what value. In this case, it's a simple DC voltage. So I'm going to say it's a 10 volt DC value. Hit OK, and you can see now it says, oh, I've got a 10 volt voltage source. Cool. Okay. So now let's add another component. And you go up here, you can see, resistor. So I'm going to left click, pick up a resistor. Before I left click to stamp it down, I decide, well, maybe I want to rotate this. Okay. So to do that, as long as it's still in my hand and I haven't stamped it down, that's very important. Before you stamp it down, when you're still carrying it in your hand with the mouse, you hit Control R and that will rotate it 90 degrees. Control R, Control R, Control R. You keep doing it and it will rotate. So we want it horizontal, so we do Control R, stamp it, left click or right click, and you've released the resistor. So again, first thing you do when you add a component, right click, tell it how many ohms. Let's say we want a 10 ohm resistor. Okay, so now I've got a 10 volt voltage source, a 10 ohm resistor. So let's say I want another resistor in my circuit. Click on the resistor, drag it over here, left click to stamp it down, right click to release. First thing you do is you tell it what value you want. Let's say that's another 10 ohm resistor. Okay, so here we go. We've got a voltage source and two resistors, so we're pretty much all set to go. So the next thing we need to do is to draw a circuit, draw a wire around this to make this a closed circuit. So you go up here to this pencil looking tool and click on it. It says wire and it gives you these crosshairs. So I'm going to start down here on my ground reference in this box, click, and that will start a wire. And I can drag it up and I can even go past this voltage source, click right here, and it's smart enough to know that I didn't want to go past the voltage source. I wanted to connect the wire at both sides, at the input and output. So it draws the wire, and then I just go over here. I can go right through the resistor, click, right through this resistor, left click, and then back here to connect it back to ground to give us a continuous circuit, left click, and now we've got our complete circuit. So I right click to release that wire tool, and now we're all set to go. We've got a complete circuit with a voltage source and 2 resistors. Now let's say, just to make this look nicer, I want to move this 10 ohm resistor, move it up a little bit so it's in line with the voltage source. Well, if I go up here, I've got these 2 hand icons. One says move, the other says drag. Okay, well let's left click on the move tool, and you can see I've picked up the move tool. You see I've got the hand icon. So I'm going to left click and release. Okay, well it allows me to move this resistor. But it's not ideal. So what I'll do is I'll put it back, stamp it back down, and right click, and go up here and try this guy. This is a drag tool. So I'll left click, pick up the drag tool, briefly left click, and so this not only moves it, but it keeps all the attached wires connected. Much nicer. So I drag it to where I want it, left click, then right click to release. So those are the basic tools you're going to use here to set up your circuit, and we'll look at some others a little bit later, but that's the basic workflow to do this. So now what I want to do is I want to simulate this. Okay, I want to see how much current and how much voltage is in the circuit, and maybe how much power is in the circuit. Okay, I want to look versus time at how much these quantities are. So I need to do a simulation. All right. So in order to run a simulation, I'm going to go up here, and you can see this icon of the person running, and it says run. So what I do is I will left click on that, and I have to tell it how long I want to run the simulation for. And I do that by entering a stop time. So I'm just going to say, just pick a number, 0.1 seconds. Okay? So it will run a simulation and simulate the voltage and current in the circuit between 0 and 0.1 second. So I hit OK, and immediately it pops up this graph area. Okay? There's nothing in it, but there's this blank graph area. Okay? And you can see I've got 2 windows now, and this is an important concept you need to get straight with this. There's 2 windows. The bottom schematic window is highlighted. You can see it's a blue here. The top one is a gray. It's not highlighted. And you can also verify this because if the schematic window is highlighted, then all of these schematic drawing tools and components are available. All right? If I then click on the graph, you can see they become unavailable. All right? So when you're doing stuff, when you've got these 2 windows, you got to make sure you selected the right window, because some things won't be available. Like if you've got this graph selected and you want to work on the schematic, you won't be able to access the tools. So you got to make sure you click the right window to select it. And you can do that, for example, here I can left click to select this window. Okay? So anyway, I'm running a simulation, and what it needs to know is, okay, I'm running a simulation, but you need to tell me what you want to see in this graph. All right? You haven't told me yet. So let's say I want to see how much current is flowing through this circuit. Well, if I hover over this circuit, you can see I get these icons popping up. And here there is looks like a pencil or something. It's actually a voltage probe icon, okay? So if I click this voltage probe at this point, it will plot the voltage at this point throughout the simulation. And if I instead move it over the component, it gives me what is a current measuring icon, okay? So I can measure current through this circuit and let's do that. Let's left click, and you can see it automatically gives me a graph of the current from 0 to 100 milliseconds, which is 0.1 second, which is what we set on the simulation. It gives us the current over time going through that resistor and going through the circuit. So we know it's 500 milliamps flowing through this circuit, or 5/10 of an amp. And that makes sense because 10 volts over 20 ohms, 10 divided by 20 is 0.5. So that's why this is such a nice tool if you're learning electricity. You can actually set up a circuit, decide before you run the simulation what you expect the answer to be, and then run the simulation and see if it happens the way you thought it would. The rule of garbage in, garbage out applies. If you put in the wrong numbers, it's going to do a simulation based on the numbers you put in, not the numbers you think you put in, okay? So don't use it as the final answer unless you're absolutely sure of your data, okay? So be very careful. So anyway, now let's say I've got the current. I want to see what the voltage is at this point right here. So left click and it automatically gives me the voltage at the point. You can see up top I've got the I through R1, it says I R1, and here's R1, so it tells me the current through R1, and that's the yellow graph, which is 500 milliamps. You can see it plots milliamps over here on the right, and the blue is V node 002, V002, which is right here, and that is 5 volts. And that makes sense because I've got 10 volts divided across two 10 ohm resistors, so it's going to be 5 volts here, 5 volts here are going to add up to 10 volts. So now let's say I want to give better names to these points on the circuit. Here I've got N002 for this point. That doesn't make a lot of sense. So what I want to do is I want to apply a name to this so I know what the plots mean. So what I go up here is go to the, select this, go up to the label net. And this is called a net for network, okay? So I want to add a label, so I pick up the label tool, and let's say I want to label this output, and I'll call it out, okay? So I've now picked up an output label, left click, right click to release, so I've now named this out. Let's say I want to do the same for this input, or the source. Let's call it source, okay? And I drop it here, left click, right click, and now I've named it. So what I can do is I can rerun this simulation, and I will select, see I've got I through this R1, let me select the output, and here it says V out, and I'll select this, and here's V source. So V source is the 10 volts up top here. You can see red, the red line for V source is up top, 10 volts, and then V out is 5 volts down here, okay? And then the current through the resistor is this over here, which is 0.5 milliamps, okay? So this is real important that you name your nodes in the circuit so you can make sense of the outputs. So now let's say I want to change this source from a DC or direct current. I want to change it to a sine wave, an alternating current. So again, I right click and it assumes I want a DC, but what I can do is I can go to this advanced tab that we showed before, and I can now choose to pick a sine wave, okay? And there's not a lot, there's a lot of input here, but you don't have to fill out a lot. You can just say I want a amplitude of 10 volts and a frequency of 60 cycles per second or 60 hertz. And that's all you need, okay? So I've got a magnitude 10 sine wave at 60 hertz. Also, let's say I want to move this label here. So again, I go to the move tool, pick it up, click on this, move my mouse, stamp it down, right click, and I've moved this, okay? So basically I've got the same circuit. The only thing I've changed is from a DC to an AC. So I can hit the simulate button. So here we go. I can show the V output, the output across the this resistor is this blue, and you can see it goes up to about 5 volts, which we saw before with the DC. And then the V source, which is the input, which is 10 volt magnitude, is this red, and it goes up to 10, down to minus 10, up to positive 10. And then the current through this resistor, you can see, is this 500 milliamps. It's these labels on the right, the axis on the right. So you can see multiple things on your graph, and all you have to do is click what you want. So now let's say I want to get rid of some of these. Let's say I want to get rid of the current. So I just go up here to the label of the current graph, right click, and go down here, delete this trace. Okay, just click that and I'll get rid of it. Or you can just change the color of the trace. All right. So delete this trace, and now we're down to just the voltage of the source. We're comparing these two voltages, okay? 10 volts and 5 volts. So now let's say I want to get a little bit more interesting. Previously we talked about a diode, which we said is like a check valve in a water pipe that only allows water to flow in one direction, and it blocks it flowing in the negative or reverse direction. So let's say I want to simulate a diode in this circuit and see if that's actually what happens. So what I can do is I can go and I want to move this resistor out of the way. So I pick the drag tool, and I can left click and select all of this and drag it out a bit, stamp it down, right click to release. Then I'll get my scissors to cut this wire, right click to release, and I'll go up here, and this is a diode. So I will pick up a diode, move it into the circuit, hit Control R a few times to put it in the right direction and in horizontal, left click to stamp it down, right click to release, and now I've got my diode. This is going to be an ideal diode. You can set actual diodes, but we're just going to use an ideal one right now. And then what I can do is go to the wire, click right here, go all the way through to the output, stamp it, right click to release, and now my circuit's all done and I've got a diode in there. So what I can do is go through and simulate and hit the run tool, and wow, here we go. We've got V out, which is the voltage at this out point, and you can see it has changed so that the voltage only goes from 0 volts to a positive 5 back to 0, and it doesn't go negative. So it's actually what we said, the current only flows in one direction, okay? So it only flows in this direction. So again, this is a great tool for putting your learning in practice and see exactly what will happen for different configurations and trying things out and learning as you go. So I hope this is helpful. It is going to help springboard you into your learning of electricity. And maybe we'll talk a little bit more about the simulator in upcoming videos. But I hope this helps. Take care and have a really good day. Thanks.